In this video, I'd like to talk about reducing rational expressions to their lowest terms. And a rational expression is essentially a ratio of two polynomials. Notice that the word ratio is in the word rational. So it's going to be a fractional expression where in the numerator and in the denominator, you're going to have some type of polynomial. And we want to be able to simplify these expressions so that they are as simplified as possible. But one thing we do have to consider is that because we do have division here, that there are certain x values that we cannot plug into our denominator since they will make the denominator equal to 0, which will lead to division by 0, which is undefined. So in our simplification process, we also need to recognize which values of x we need to exclude from the domain of these expressions. So to simplify this, and in most of these problems, you're just going to need to factor the numerator and denominator. So let me just rewrite these. So we have x squared minus 25 over x squared plus 9x plus 20. And first recognize that this numerator, this is a difference of two squares. Recall that when you have a squared minus b squared, that this is equal to a minus b times a plus b. It's the first one without the square minus the second one without the square, and then multiplied by the first one plus the second one, again ignoring the squares. So we can do the same thing here since 25 is really just 5 squared. And so this becomes the first one, x, minus the second one, ignoring the squares, multiplied by the first one plus the second one. And you can always check these by just redistributing and multiplying everything out to prove to yourself that this is just x squared minus 25. Now in our denominator, we're going to be able to factor this quadratic into a product of two binomials, just like the numerator. And for this one, each of these has two terms, and the first terms will have to be x and x, since the coefficient on x squared is just 1. If it was a different coefficient, you would need to use the grouping method for factoring, but since the coefficient is 1, we can use this faster method here. And what we can also recognize is that this term and this term here, they're going to be numbers, and they're going to multiply to 20, but they will also add to 9. So let's consider 20 and what numbers multiply to 20 here. So we can have 1 and 20, we can have 2 and 10, or we can have 4 and 5, or we can have where they're each negative, minus 1 and minus 20, and so on. But we really only need to know the positive numbers because we know they're going to add to positive 9. And so which of these pairs adds to 9? Well, that would be 4 and 5. So we'd have x plus 4 and x plus 5. Now, from this step, we can determine which x values we need to exclude from the domain. Since we're essentially looking, when does this product in this denominator equal 0? And to answer that, we can use our zero product property. So notice if we plug in negative 4 here, we would get 0 multiplied by 1, which is 0. So x cannot be negative 4. And if we plug in negative 5 here, we would get 0 multiplied by negative 1, which again is just 0, since 0 multiplied by anything is 0. So this will answer the second part of the question, which x values we need to exclude. It would have to be negative 4 and negative 5. But to be able to write this in its lowest terms, we need to make a cancellation. Notice that we have x plus 5 in the numerator and x plus 5 in the denominator. So something divided by itself, those are going to be able to cancel out, and we're just going to be left with x minus 5 up top and x plus 4 down below. So this will be our fully simplified expression. So just to summarize, the general strategy is to factor the numerator and the denominator and see if you can make some type of cancellation here. and to always recognize which x values you cannot plug into this denominator, since those will lead to division by zero. And so in the next two videos, we're going to look at several different example problems from two different exercises on the Khan Academy.